Okay, in this math lesson, we're going to be reviewing the skill of dividing decimals, which is a little bit unique. It's a little more involved than the other decimal operations, but that's okay, we can do it. So we'll start off by going over the key ideas, and then we'll put those key ideas into practice through 3 example problems. So when you divide decimals, first off, you need to make sure that your divisor, and little math vocab. If this is my division problem, just making up random numbers, the divisor is the number that's on the outside of I'll call it the decimal house. Some people refer to this as decimal house division. So the divisor is the number on the outside. The number on the inside, just as an aside, is called the dividend. So now that we've got our math vocab down, when you divide decimals, you need to make sure that your number on the outside, called the divisor, is a whole number. So in the made-up example that I put on the screen, we can see that there is a whole number on the outside. We would be good to go with dividing here. If the number is not a whole number, so let's say this was 1.3, for example, and let's say that this was 2.67. It doesn't matter what's on the inside. The inside could be a decimal, a whole number, it doesn't matter. But the number on the outside, we need to make a whole number. And we can do that. If it's not a whole number, just move the decimal to the right as many places as you need to make it a whole number. So in this case, if I had 1.3, I would need to move the decimal over one place value to make it 13. So then I would have 13 on the outside. However, we got a big but. If you move the number on the outside, you must also do the same to the number on the inside. So whatever you do to this number out here, you moved it over one place value, you have to keep things even and move the decimal the same amount for the dividend, the number on the inside. So that would make this problem 13 and 26.7. Those would be my two numbers. Don't worry, you're going to get the same exact answer. If you wanted to really check, you could put 2.67 divided by 1.3 into a calculator. And then you could put in 26.7 divided by 13 into a calculator. And you know what? You would get the exact same answer for both division problems. When you move the place value the same amount for both numbers, it will not affect your final answer. And then you don't have to deal with any weird decimal things on the outside. You can do long division as you normally would. Now, I've said a lot of things. Let's put it into practice with an example. The first problem I have is 18 and 2/10 divided by 1 and 4/10. First off, you need to know how to set up a division problem. So make your little house or whatever you want to call it. Your dividend, the number inside, is the first number. So that goes on the inside, 18 and 2/10. And your divisor, aka the number that goes on the outside, that's the second number in a division problem. So 18.2 divided by 1.4, that's how you would read this. 18.2 divided by 1.4. Now, instantly you should recognize that on the outside number, your divisor, it's not a whole number and we need it to be. So we're going to move the decimal over one place, which means I also have to move the decimal over one place here. And so it's a little cleaner. I'm just going to rewrite my problem. So now I've got 14 as my divisor and 182 as my dividend. And now I can divide as I normally would. So how many times can 14 go into 18? It can go in one time. And I'll subtract. 18 minus 14 is 4. And I'm going to bring down the 2. How many times can 14 go into 42? It can go in 3 times evenly because 14 times 3 happens to be 42. And so that tells me the answer to this division problem is 13. And the only thing that we had to do extra before we could do our long division was move the decimal over once in the divisor to make it a whole number, and do the same thing to the dividend. In the second example that I'm going to go through, we're first going to set up our house. So 32 divided by 1.25. And since my number on the outside, the divisor is not a whole number, 1, 2. We're going to move it over 2 spaces so that it is. Now it's 125. Now, whatever you do to that outside number, you must replicate for the inside number. So first off, where is the decimal point? I don't see a decimal. Well, every whole number has a decimal right at the end. And since we moved it over twice, for 32, we're going to move it over twice. That moves it here. And I need to add in some placeholder zeros. Ooh, so now I've got 3,200 as my dividend. And now I can do my division as I normally would. So how many times can 125 go into 320? It can go in 2 times. That would be 250. Subtract, and you get 70. We're going to bring down this extra 0. How many times can 125 go into 700? It can go in 5 times. 125 times 5 is 625. Subtract, and you get 75. And we don't deal with remainders. We're going to get an actual final answer here. So since there are no more zeros to bring down, and I need one because 125 can't go into 75, I'm going to add a decimal here because I don't want to change this. This is 3,200. I can't just add a 0 because then it would be 32,000. So it's still 3,200. We're adding a decimal. And anytime you add a decimal to your dividend, to your number on the inside, you bring that decimal straight up so that it's in your answer as well. And we're going to add a 0. So now I have a 0 to bring down. How many times can 125 go into 750? It can go in 6 times, and it can go in 6 times evenly, which means I am now done. So how many times can 1.25 go into 32? 32 divided by 1.25 is equal to 25.6. And if I'm taking a second to make sure my answer makes sense and is reasonable, that's definitely reasonable. 1.25 can go into 32 about 25 or 26 times. That seems reasonable. Always check to make sure your answer makes sense. Sometimes you might have put your decimal point in the wrong place, and then you'll have a really unreasonable answer. For our last example, we're going to do a word problem. Word problems are good for you. This word problem, we're going to determine, first off, is it a division word problem? Why is it division? And then we'll set up the division and solve it. So it's asking how many times more cell phone subscribers were there in 2015 than in 1990. So if you look at this chart over here, in 1990, it shows us that there was 5.3 million people who had a cell phone in their possession. So 5.3 in 1990. And we're comparing that to 2015. So if I go to 2015, it's right here. In 2015, 377.92 million people. It's a big difference. We're in the hundreds of millions compared to just 5 million, which makes sense. Pretty much everyone has a cell phone these days. Now the question is asking how many times more. Anytime you're trying to find how many times more of something, it's going to be a division problem because you're working backwards. Think about it. We're asking 5.3 times what gets us to 377. So to figure out how many times more, we need to divide those two numbers, and that'll tell us how many times more people. So this is definitely a division problem. I can see it by the language and just by interpreting what it's asking. So let's set up the division. We're going to be dividing 2015's cell phone subscribers by 1990's cell phone subscribers. And I can clearly see The problem is I need to move my decimal over once, so I do it in both numbers, rewrite the problem, and now I can do my division. And okay, here we go. 53 can go into 377 7 times, and that's 371. Okay. So when I subtracted, I got a 6, and then I brought down the 9. So I've brought something down already. 53 can go into 69 one time. Subtract, and I get 16, and I'm going to bring down the 2. Now pay attention, you've got a decimal in your dividend, so I'm going to bring it up into my quotient to make sure it's in the answer. And then last, how many times can 53 go into 162? It can go in 3 times. And that's 159. Subtract, and you get 3. We don't have to go any further because it says round to the nearest whole number. And so you need to go one extra place value, which we've done, and now we can round. So 71.3 rounded to the nearest whole number. I look to the right, it's less than 5, so I just round it to 71. So that tells me there are about 71 times more people in 2015 that have a cell phone than there are in 1990. And that seems to be pretty accurate. It went from 5.3 up to 377. That's being multiplied by about 70, and we got 71. So anyways, that's your lesson for today. Dividing decimals. Take your time. Definitely need to show your work, and go slow. Don't rush. If you have questions, reach out on the Google Meet, and we'll see you next time. Bye-bye.